Hi, good afternoon, all. Your topic today is all about controlled experiment, but we're going to do a little bit of the review of scientific methods. And let me just turn off my cam. Okay. So the first slide shows you the role of science in our lives. Three picture clues here. We have the discovery of fire, we have the gravity, and then friction. You can see here a dirty feet with some blisters right there. Okay, so what's the goal of science? Science basically explains different phenomena that we see all around us. On top of explaining these phenomena like fire, gravity, and friction, it also proposes solutions to some problems. So those two are the major roles of science in our lives. And these steps are not strictly to be memorized like okay, first step is make observation, then ask questions, make hypothesis. The basic point about scientific method is that science always follows specific steps, in orderly steps in solving problems. So typically these are the standard steps. Of course, we need to observe, we need to use our senses in order for us to enable to ask questions. And from our questions, we can create our guess, our hypothesis, as we call it. And then we can try to prove it by conducting an experiment. And then after the experiment, we can either conclude whether it's based from your hypothesis, you can make a conclusion whether it's correct or wrong. And then you can always repeat your result, report your result, and always repeat the procedure or repeat the experiment. In more details, let's look at each step, like what are the things that we need to remember for every step. And I want you guys to pay attention to what we put here on the side. Okay, so number one is we all need to make observations. How do we make observations? We use our senses. Okay, we use our sense of taste, smell, hear, see, touch. And then the next step would be, so when you're observing, let's say you smell something, right? You smell it and then you sort of say, oh, what's that smell? I wonder what's that smell. So you moved on to the second step, which is state the problem. A problem should always be in question form. Remember that, always in question form. For example, how does temperature affect the enzyme? The third step will be create your hypothesis. Hypotheses are your tentative answers, your predictions, and we have a way of stating it. Follow the format, please, like you follow the if and then. For example, if thicker paper is used, then it will be harder to shred. So you give your condition and you give your possible answer. The fourth step will be to test the hypothesis, like you're going to do it via experiment, and that's when you say you test it. Fifth step will be conclusion, or the answer to your experiment. And then finally, you're going to have your result, which you will report. And last but not the least, in order to make your experiment result valid, we'll have to repeat the experiment. Okay? This one is about designing controlled experiments. So what's a controlled experiment? Remember this. Controlled experiment will always follow a format of having two groups. Okay? So let's look at the picture, the picture clue here. We see two flasks, right? The only difference between these two flasks, they both have liquids inside, they both have the cover, the cork, and they both have the glass tubing. The difference between the glass tubing of this one is straight and short. This one goes like with bends and curves. So let's look at question one. What's the only difference between the two flasks? And I think we've already answered that, and that would be the glass piping. Number two, list at least three things that are the same in both. Okay, I'll give you a few seconds to think about it. Okay, so three things that are the same in both. You can say liquids inside. We assume they're the same with a color clue. We have the same flask and we have the cork. These are things that you see. There may be other things that are the same that we do not see. For example, temperature or pH or humidity. But since we don't see it here on the picture, there's no quantitative explanation, so we don't say that. Number 3, which between the two flasks was controlled by the experimenter? Choose. Okay, so controlled by the experimenter means you don't change the setup. So we would say it would be the left. So this one will be your controlled group. Okay, controlled group. Let's look at the second slide. So what does a controlled experiment look like? This will show you a different example, but the same concept. So it has two groups. Let's look at the picture here. Picture clue. You have a pot, two pots actually, the same plant. And let's just say whatever is inside there in the pot, like the soil, the water, will be the same. And the only difference here, this one is receiving water. And then this one is receiving Coca-Cola. Okay? So what does a controlled experiment look like? It has two groups. And we call the two groups as the control group and the experimental group. Control group is without the experimental treatment. Or otherwise known, you could say it contains the placebo. So let's look at the example here. Between the two, which one is without the experimental treatment? Okay, you might ask, what is the treatment? Well, that is something that's the setup is not normally supposed to receive, and that is the Coca-Cola. So the group without the experimental treatment is this, the one on the left. Therefore, this is your control group. Let's look at the definition of experimental group. Experimental is with the experimental treatment. So your treatment is the Coca-Cola, and therefore this group is the experimental group. So identify the control group and the experimental from the given. Indicate by either left or right, and we've already answered that. So let's move on to the next slide. So what does a controlled experiment look like? Both groups have all treatments or variables the same except for the independent variable. So now we have an additional term here. The first term that we learned from the previous slide is control group. This is the control group. This one, the second term that you learned, is experimental group. This is the experimental group. The third term that you're asked to learn is independent variable. So variable is just a material. It's a treatment that you give to the experimental group. Because this is the experimental group, that Coca-Cola is your independent variable. So I want you to think and remember this. Everything is the same except for one thing. That one thing is the independent variable. And the group that receives the independent variable is known as the experimental group. Okay? So independent variable is purposely changed by the investigator. It was sort of controlled or decided to be given to that group. Okay? So we already answered this. Name the independent variable. In this case, is the Coca-Cola. All right, let's look at this slide. Let's start with the question, so at least you can think, as we discussed. Name at least two constants in the given example. So this is now the fourth term that you need to learn. Constants. Okay? So how does a controlled experiment look like again? Third concept. All similar treatments in both groups are called constants. So again, treatments are also the material. So everything that's the same in this group and this group are called constants. Okay, so everything will be the same except for that one thing. That one thing is called the IV or independent variable. So let's list down a few of the constants. You can have the pot, you can have the type of plant, the amount of light received. Those are three examples of constants. Okay. Fourth concept, let's look at the question. Name the dependent variable from the given example. So this is now your fifth term that you need to remember, dependent variable. The data are collected from both groups. So imagine this, at the end of the experiment or during the experiment, you're collecting data. These data are measurements, are numbers, are observations, okay? So those measurements that you collect, those data that you collect are called the dependent variable. In this case, we assume that, the water is given to the plant, and we try to observe if the plant will grow, how much it grows. Same way with this one, Coca-Cola is given to this pot, and the plant is observed for its growth. Therefore, the dependent variable is the growth of the plant. Okay. So let's review. Let's review again. I'm going to go back to all the slides and remember the following concepts. So in a controlled experiment, you have two groups. You have the control group and the experimental group. The control group, how do you know it's control group? Well, because control group does not receive the IV. Independent variable is that one thing that is given to that experimental group. Everything is the same. And those things that are the same are called constants. Okay? And at the end of the experiment, you make measurements, and those measurements are called dependent variables. So I hope this helps, and I'm going to stop the recording now. And